Chapter 4 review, pre-calc. Hopefully you find this very useful. I don't know if it will be in multiple parts. Hopefully not, but we'll see if I can get this all done in the time I have. So the first problem, to convert degrees to radians, you can either use dimensional analysis or you can use our proportional reasoning. So 405 degrees times diagonal from the 405 needs to be the degrees. Our conversion fact, 180 degrees equals pi radians. So you can either multiply or do proportional reasoning, but that's negative 405 pi divided by 180. Strongly recommend using your calculator for these. 405 divided by 180 math fraction is 9/4, so negative 9/4 pi is your conversion. Find a positive angle less than 2 pi that's coterminal. Now remember, coterminal is the same angle, it's just a different number of rotations. So this is going clockwise, negative 1 over 110, so it's a really tiny angle. So what we want to do is we want to go counterclockwise. So we'll add 2 pi to this. Now that's 2 pi over 1, so we have to get a common denominator. So that's negative 1 pi over 110 plus common denominator is 110. So let's multiply top and bottom times 110. So that's 220 pi over 110. My 110s aren't looking so good there, sorry. And so when I add those together, I get 219 pi over 110. You can try to reduce that. It's not reducible. And there is your coterminal angle that is less than 2 pi. Next one, the first thing we have to do is we have to convert 240 degrees into radians to use our formula. So let's do that. 240 over 1 times pi over 180, your dimensional analysis. So 240 over 180 4/3. So 4/3 pi. Arc length is your radius, 11 times 4/3 pi. Type your answer in terms of pi first, so that's 44/3 pi, and then an exact. Is 46.0. Checking my decimal points. 008. Okay, you can see we did that one in class. So 7/12 of the clock times 2 pi is 7/6 pi. Your arc length then is 7/6 pi times 8, or 28/3 pi. So now calculate 28 divided by 3 times pi, and that is 29.32 inches. Okay, using the trig circle, find the value for tangent. Now on the test, you're going to be required to create your own trig circle, at least for the final. So I would get used to creating this. Now for this particular problem, 2/3 pi, and we want the tangent of 2/3 pi. So that is this number right there. So our tangent is sine over cosine. So it's rad 3 over 2 divided by negative 1/2. You can divide straight across for these, and so the 2's will cancel, and it's negative rad 3. Same basic idea for cosine of pi over 6. Even or odd, I would just go ahead and use the trig circle and go to negative pi over 6 and grab the cosine of that. It's rad 3 over 2. It's much easier than using even and odd functions. So, and there's the cosine of rad, or pi over 6. Here's the cosine of negative pi over 6. Okay, 11 pi over 6. Again, we'll just go, you can either use coterminal angles, or you can just look on your trig circle, and oh gee whiz, look, we just repeated the same problem. And then negative 11 6 pi plus 2 pi over 1 is negative 11 6 pi plus 12 6 pi. Add those together, that's pi over 6. So looky here, it's rad 3 over 2. So hopefully you don't have any issues with reading the trig circle at this point. Okay, on this guy, I wouldn't use that identity. I would draw a triangle, and sine is opposite, so from theta, opposite square root of 6, hypotenuse is square root of 7, sorry, and hypotenuse is 6. So let's make this x squared plus square root of 7 squared equals 6 squared. X squared plus 7 equals 36. That's 29. So x equals the square root of 29. So your cosine is adjacent over hypotenuse. So that'd be the square root of 29 over 6. Okay, I would again use my coterminal angles. So negative 9 pi over 4 plus 2 pi, common denominator. So that would be negative pi over 4. Now you can use a trig circle from there, or you can add another 2 pi, but negative pi over 4 is this angle right in here. So we're looking for the secant of that. So that would be 1 over, let me just scroll back up just a hair here. That's 1 over your cosine. So 1 divided by square root of 2 over 2 is the same as 1 times 2 over the square root of 2. Rationalize that by multiplying numerator and denominator times square root of 2. And you end up with just square root of 2. Okay, most of these I think are pretty easy once you get to the pattern of them. So first we want to find the missing side length A. So we're going to use the Pythagorean identity to do that. So that would be so 625 and 576. Now we'll subtract those and take the square root of it. So we'll fill that in as a 7. Now all we have to do is read the triangle for SOHCAHTOA. And I would write this at the top of your test right off the bat too. So sine is 7 over 25, cosine is 24 over 25, tangent is 7 over 24. And then these are just reciprocals, so 25 over 7, 25 over 24, and 24 over 7. Okay, cofunctions, remember, are just 90 minus x, or its equivalent in radians, pi over 2 minus x. So the cofunction of cosine, first of all, is sine. And it would be pi over 2 minus pi over 4. So common denominator.